So today we will be doing the HYPERMESH isotropic analysis of a suspension connector using OPTISTRUCT. So first go to user profile and see whether OPTISTRUCT is selected and click on OK. After that we need to import the geometry. So you can import the geometry by clicking on the files and going to the place that you want. So click on open. Let's see, and click on import. Okay. Once the file get imported, click on close. Now we need to give a mesh, so go to geometry. Now go to 3D and click on tetra mesh. Select the complete body and mesh it. Make sure that you have ticked on use curvature and use proximity, and the element size I am giving as 1 mm and click on mesh. Now you can see that the mesh is created over here. Now click on return and you can see the mesh. Okay. Now you need to create a material. So for that go to right click over here, go to create and select material. In the material, the values that are given over here are by default for the structure steel. If you need to give it for the aluminium or some other material, you need to know the Young's modulus, shear modulus, Poisson's ratio, density of that material and give it over here. For the card image, for the isotropic material it's mat 1 and for the composite material it's mat 8. So select the card properly. Then once the material has been created, create a property. Okay. Now in the property, make sure that you have selected the card as P solid, as it is an orthotropic isotropic solid. Select the material as the material that you have created and click on proceed. And isotropic, select full. Okay, once the material is created, you need to assign that material and property are created. You need to assign the material and the property to the part and select property and apply. Okay, and over here also property. Okay. Once the material and the property are given to the component, now we need to create nodes so that we can apply forces and constraints. So for that, go to geometry and click on distance. Now you can select 3 nodes at the edge of a circle and create a center node. So for that, go to distance and 3 nodes and select the 3 nodes and circle center. Okay. Similarly on the other side, 1, 2 and 3 and circle center. Now select on 2 nodes, as we need to create a node between these two. So select the node properly. Okay, and nodes in between. Now this node is created. Now similarly we need to create a constraint node. So for that, over here the constraint 1, 2 and 3 and circle center, the node is created. Similarly over here, 3 and circle center. Now again go to two nodes, select the first node, second node and node between. Okay. Now we need to create a node over here. So again go to three nodes, select the three nodes and create a circle center. Similarly over here, 2, 3 and circle center. Now the required nodes have been created, but along with the required nodes there are few nodes that we don't want. So for that what you can do is click on shift and F2 at the same time and select the nodes that you want to delete. So 1, 2, 3 and the fourth one. Okay, and clear. Now you can see HYPERMESH has deleted the nodes that you have selected. Okay, so there are total of 4 nodes, proper nodes. Click on return. Now you need to apply a constraint. So for the constraint you have to apply, it's better to apply on one node rather than applying on one node, each of one node over here. So go to create and create a component. Okay, so RB3 is a component, so you need to assign a different component for it. Make sure that is RB3 is current. Okay, it's current over here, you can see RB3. Return and go to 1D and go to RB3. First you need to select the dependent node and then the independent node. So for that aligned it properly, and as you can see it's getting a square selection. To change it from square to circle, click on shift and right click and select circle, and then click on shift and select the nodes that you want to select, and the nodes are selected over here and create. RB3 is created over here. Now similarly over here, so select the dependent node and the independent nodes and create. Okay. Now similarly over here you can do it, but the problem is if you select if you use a selection tool over here, it would select all the nodes over here. So you need to select each node manually. So the dependent node and then the independent nodes. So 1, 2, 3 and so on. Now as you can see, all the nodes that I want are selected over here. Okay, so now create. Similarly create over here. Now all the nodes and the dependent and independent nodes have been selected, and click on create. This would create an RP3 over here. So now go to return. Now we need to give the forces and the constraints. So first we will be giving the constraint. So the constraints we will be applying on this node. So for that, go to analysis, constraints, select the node in which you have to give the constraint, and click on create. Now you can see a constraint is created over here. Okay, see, a constraint is created over here with all degree of freedom restricted. Now we need to apply the forces on this 3 parts. this three nodes. So go to return, and in analysis itself go to forces, and in the forces I need to apply, means you can apply the forces in the direction that you want, the resultant direction also, but for now I'm applying on this node in the x direction, negative x direction, and create on this node as, you can change the magnitude over here as positive 1000 over here, create, and on this node, okay, I selected the wrong node, go to the and forces, and for this node in the, I'm applying it in the positive y direction and create. Okay, now the forces are created, forces and the, okay, now you can't give the forces and the constraint in the same load collector. I've done the mistake over here. So for that, click on Ctrl Z and remove all the forces, and click in this white space over here and create a load collector, forces, and again go to the forces, select the node, create. Select the node, give the axis and create. Select the node, change the vector and axis is same and create. Okay, now this is done. Okay, now go to return, and we need to create a load step for it. So check whether the auto is our SPC and force is the load is the F. So create. Now you can see a load collector is created over here. Now go to return, and once the setup and meshing setup, loads, everything is done, go to OPTISTRUCT, save the file in a different folder, because HYPERMESH tends to create different files for a single analysis, which might confuse you at the later stages, and save it over here and click on OPTISTRUCT. Okay, you can see the progress of the analysis over here, the iteration and the convergence. Okay, so as you can see, the 30% progress is done over here. Now you can see the analysis is done over here. The deflection is about 0.1495 mm. Now if you want to see the results, you can click on the results. It would automatically open the results in the hyper view. So click on results. Now as you can see in the hyper view, it has opened, and you can see the forces. If you want to hide the RB3, just hide it. Okay, and now to see the deflection, go over here and click on apply. Okay. Now over here there are minimum deflection, and the highest deflection is over here. It is about 0.2 mm. Okay, so for the animation you can see over here. Okay, it's not changing. It's fine. For stresses, you can see and click on apply. So you can see the stresses, the maximum stress is generated over here, and the analysis is done now. So thank you.